Okay, y'all took y'all's test on Friday, and so you've seen that. And like I said, really we're not finished with this unit. It's just we have to get 2 test grades in before the 6 weeks is over. And next Friday, so like 2 weeks, the 6 weeks is already over. So we're going to be taking a test on next Tuesday to get our 2 grades in. So going by fast, we're already nearly to the end of the 6 weeks. So, all right, on this first one, draw and define arrays. So look back at your vocabulary. That vocabulary page, I think we did back on the 27th. The Geometry 1 unit, or Geometry Unit 1 vocabulary terms. Somebody look back on there. Whoop. Just dropping everything.
I know, today's not my day.
Okay, so what is array? Look at the definition. Look at the definition on that vocabulary page. What is array?
A piece of a line with an endpoint that makes an exact
Infinitely, or in one direction. Okay, good. So array is this. You have an endpoint like this, and then it continues out from there. So array has one endpoint, and then from there it goes on forever. Okay, next. So what is an angle?
2 lines that meet at one point.
Okay, look at the definition on your vocabulary page. What is an angle?
2 rays that have a common endpoint.
Good. 2 rays that have a common endpoint, so it's like this. You have one ray like this, and then another ray that starts from the same endpoint but goes in a different direction. So that creates an angle. You have 2 rays. Okay, next one is draw and define an opposite ray. Now we really haven't talked about an opposite ray yet, but what it is basically it's this, it's an angle, but the 2 rays, instead of just going in 2 random directions, they go in the exact opposite direction. So it's like this. You have one ray going this way, and then another ray going in the exact opposite direction like this. Which actually just ends up making a line. So really it's easier just to draw a line and just put a dot in the middle. That's the same thing, really. So you have 2 rays there. Okay, so here's an angle. Now, as you think about what we've already talked about, just this part right here that I'm highlighting in black here, what is that? Okay, good. That is a ray. Now, by itself, it's a ray. But if I think of the overall bigger picture of that whole angle, we call that a side. Okay? By itself, it's a ray, but as a part of an angle, we call it a side. It's a side of the angle. So then this thing over here, what's this? Okay, by itself, it's a ray, and as a part of an angle, what is it? It's a side. Okay, next thing, this right here. By itself, what is that? Okay, it's an endpoint, or just even more generally, it's just a point. Now, as part of an angle, somebody remember or know what we call that? Not the origin. Origin's a good guess, but it's... Okay, good. Vertice is plural for this word. It's just a vertex. Good job. Y'all are calling up some old stuff there. We haven't talked about this year, so that's good. That is a vertex. Okay, now let's go back and let's talk about naming these pieces of this. Okay, so I'm going back to this thing right here. What did we say that this was by itself? Is a ray. Okay, and we've talked about how to name rays. So how would I name just that ray, just that side? Okay, it's not a point by itself. It's a what? It's a side, but by itself, what is that? It's a ray. So what would I name that ray? Okay. Okay, remember, you don't name a ray by a single point. It's like a line. For a ray, you've got to use 2 points. So what would the name of that ray be? Okay, good. It is ray XY like this. That would be the name of that. Now again, on rays, the order of the letter matters. So you've got to put that end point first. So see how X is the end point? Notice how I put it first here, and then the arrow's drawn that way. Starts at X, and then it goes through Y. Okay? Down here on the bottom part, okay? Let's name this ray right here. What would I call this ray? Okay? What would I name this ray? Not just Z, because Z is a point, and I wouldn't name it just X, because X is a point. It is ray XZ. Okay? On the stuff that you're going to be doing a little bit, you will be naming stuff like this. Okay? And now the vertex, just by itself, what would I name that vertex?
Point X.
Good. Point X. All right, now let's talk about naming the whole angle. Okay, so now I'm talking about naming this whole angle here. Okay, so here's the one way I can name it. And this is the symbol. That right there is the symbol that we use for angle. So you're about to see me draw a bunch of those. That's just the symbol for angle right there. So one thing I could call this is angle YXZ. That would be good. Okay, another name that I could give for this is I could call it angle ZXY. Okay, so as you look at both of these names right here, YXZ and ZXY, do you notice something that's common between these two names? Good. The X is in the middle here, the X is in the middle here, and that's not by chance. It's got to be that way, okay? So what is X on this angle? It is the vertex, right? So I want you to write a note down about this. This is very important, okay? The middle letter is always the vertex. Okay? When you're naming an angle, the middle letter is always the vertex. It's the way it has to be. If you think about it's going in order, it makes sense. If you don't put the middle letter, then whenever you're looking at it, it just doesn't fit with what the picture is. So when you're naming it, make sure you always name it where the middle letter here being the vertex. Now on this one, there's actually two other ways that I can name it. If you'll notice right here, there's a 3. So that's another name that I can give to this angle is angle 3. Which here, really the 3 is not necessary because there's only one angle, so it's not that difficult. But in some of the stuff you're going to see, there's going to be angles all over the place. And then in that case, it's good to have a number. But here it's not that useful, but it is there, so we can name it that. Now on this angle, I can also name this angle X. Okay, on this one, I can name it angle X. Now there's sometimes when you cannot just use a single letter, and I'll show you an example of that in a little bit. But on this one, you can use angle X, no problem, that's fine. Now let's talk about some ways that you could not name this, some ways that would be wrong. Okay, so let's say I named this angle Say I named it angle XYZ. Okay, so what's wrong with naming it this way?
Y is not a vertex.
Good. If you notice here, I put Y as the middle letter. And over here, Y is not the vertex. So this right here would not work. If you were looking at that angle and you gave this as the name for it, that problem would be counted wrong. This is the wrong way to name it. You'd get that wrong. So give me another way that would be wrong to name this same angle.
Y, Z, ZX.
Okay, YZX. Would that be a wrong way to name this angle?
Yes.
Yep, again, the middle letter is not the vertex. And if you think about it, just think about YZX. If I go over here and go YZX, that does not match up to what's going on here. YXZ or ZXY is the only way to do it. Okay. Interior and exterior. What does interior mean? Inside. And that word is spelt wrong on here. Sorry about that. Interior means on the inside. What does exterior mean? On the outside, if you think about it, the EXT is like exit, like you exit to the outside. Now, the interior points are going to be the points that are in the shortest distance between the two rays. So like from here to here is way shorter than it is from here all the way around to here. So the dark blue on here is the interior. The light blue is the exterior. So what points are on the interior?
SQ.
Okay, S and point R. Q is actually on the angle, so it's not interior or exterior. It's just on the angle. So Q, M, and N aren't going to be in either of these. So what are the exterior points? Okay, is point P and point, whoops, just going to put an A there, point O. All right, so let's kind of practice that a little bit. So on here it says name all the angles that have B as the vertex. So if you'll notice, B is right here. Okay, so what angles have B as a vertex?
Angle ABC, ABD.
Okay, angle ABD. Let me just, don't do it on yours because it's going to turn into a mess, but this right here, does that angle have B as its vertex?
Yes.
Yes, it does. And so what would I call that angle? Okay, angle ABD. Or I could flip it around and say angle DBA. Either one of those would be fine. I'm not going to write all the different possibilities. Okay.
Angle DBC.
What else?
Angle DBC.
Okay, angle DBC. Does this angle right here have B as its vertex?
Yes.
Yep. So angle DBC. And is there any other angles that have B as the vertex?
DBK.
Well, that's really the same thing as DBC. Because it still goes through all the same points. There's one other angle up there that has B as the vertex. So what if I have an angle like this right here?
ABC. Oh, it's not flat.
Yep. So angle ABC. That's a straight angle right there, 180 degree angle. Thank you. Okay, now going back to this ABD right here. Okay, ABD is this one right here. What's another way, an easier way I can name that same angle?
Angle B.
I could name it angle 1, right? So instead of this angle ABD, I could have just put angle 1 here. All right. Okay, next one. What is, name the sides of angle 3. So here is angle 3. So remember, what is the side of an angle? What makes up the side of an angle?
The ray.
Remember right here, it's a ray. Right, so the sides of angle 3 are 2 rays. So what's the name of those 2 rays?
BC and CD.
Okay, nearly. Be careful. The order matters. Okay, so CB and CE. Those are the two. All right, so CB and CE. Just a little bit. Okay, what's another name for angle GHL? What's the easy way to name angle GHL? Okay, GHL is right there. You can see GH and L. So what's the easy way to name it? Angle 7. That'd be the easy way. Okay, the last one here is name a point on the interior of DBK. So DBK is this angle right here. So what point is on the interior of this angle? There's only one point on the inside of there. What is it? It's right there. It's point E. That's the only one on the inside of that angle. Point E. Okay, so what I want you to do now is to answer those 4 down there at the bottom. Okay, so what is the vertex for angle 5? Okay, good. So here's angle 5 right here. So C is the vertex for angle 5. Okay, name the sides of angle 5. So what are the sides of angle 5?
CGCA.
Okay, so CG is one side. Okay, so that's this one, like from here to here. So could I have given another name to this ray right here? Instead of CG, could I call it something else? If you called it CJ, that would be fine also. That'd work perfectly. So on this side, if you have CG or CJ, either of those are good because they start at the same point, go through the same point, so that's good. All right? Then this other side over here, so what can I call this side? I could either call it CA or CB. Either of those two would work here just fine. So I'm just going to put CA. Okay, what's another name for angle ECL? Is angle 4. And then name a point that is in the exterior on the outside of CLH. So CLH is this line right, this angle right here. So this one's asking for the exterior. So which points are on the outside of that? It's this one, either D or E. So either of those would be fine there. All right, on the back. Different than what we talked about over here, because when you look over here at this one, how many angles were here?
Just one.
There was one. So whenever I call this angle X, is there any confusion about what I'm talking about here? No, I know exactly what you mean if you're talking about angle X. Okay, so this whole thing right here, what do you call this little instrument right here, this tool? It is a protractor. And you may know how to use it. You may have no idea how to use a protractor, but whenever you get done with this class, you will know how to use one because we're going to use it a bunch. You will know how to use that. Okay? So on an angle, this point right here, what do we call this?
Origin.
Well, it's an origin, but like what do we say on the front? What do we call this?
Vertex.
It's the vertex. Okay, what do we call this part of an angle?
Array.
It's a ray, or as part of an angle, what is it?
Side.
It's the side of the angle, and this right here is the side of the angle. Okay, this angle right here, how big is that angle?
Which one?
How big is that angle right there?
50 degrees.
It is 50 degrees. Right? Because if you think about it, is that angle more or less than a 90-degree angle?
Less.
It's less than, so you know it's got to be the smaller numbers there. Okay, it's got to be the 50. It cannot be the 130. That wouldn't make sense. But we will definitely talk more about that as we go through. We'll talk more about that tomorrow. Okay, this angle right here, what type of angle is this?
Oh, right.
This is a right angle. It's got this little mark on it right here. That means it's a right angle. So how big is that angle? Okay, it is exactly 90 degrees. It's exactly 90 degrees. It's not 90.1 or 89.9. It's exactly 90. Okay, this angle here. Now, I'm not asking for the exact measurement, but just in general, what type of angle is like this? Okay, it's acute. And what's true of acute angles? As far as how big the angle is, how many degrees? What's up with it?
45.
Okay, so it's like this. So this angle, however big it is, it's between 0 degrees and 90 degrees. It's like this. An acute angle is greater than 0. It can't be equal to 0. That wouldn't make sense to have a 0-degree angle. And the angle has to be less than 90. Okay, what if I put this little mark under it right here? What does it mean to put that little mark under it? It means, yeah, closed dot, good. You're calling on your Algebra 1 skills, but it means the equal to. Could an acute angle be equal to 90 degrees? No, if it was 90, it would be a right angle. So can an acute angle be equal to 90? No, so this line should not be here. It's between 0 and 90. Okay, and again, I'm not asking exactly how big this angle is, but just in general, what type of angle would that be? Obtuse. Okay, so what's up with obtuse angles? How big are they?
No.
They're from, good. So an obtuse angle is from 90 to 180. Obtuse angle is bigger than 90, but it's less than 180. So anything between there, like 91 degrees, 92 degrees, or jumping all the way up to the top side, it could be 179 degrees, or for that matter, it could be 179.8 or 179.9. That's still obtuse. It's less than 180, but bigger than 90. Okay, so real quick, all we're doing is just doing a general classification here. So angle MJP. So MJP, is it right, acute, or obtuse? MJP. Notice right here, MJP. What is this? See that right there? It's a right angle. Okay. What's up with LJP? It's obtuse. Okay, LJP is this one right here. You see how that's bigger than 90 for sure. And then what about NJP? It is acute. Now, I want to do one more thing here real quick. So this angle right here, this angle that I'm highlighting right here, highlight that on yours. Okay, what could I call that angle right there? What could I name it? Yeah, it's acute, but like naming it, like with letters, what could I call it? Okay, so it could be angle MJL. What else could I call it? Angle LJM. What else could I call it? Okay, angle J. Now, I kind of set the trap for you there because I didn't really tell you any different. But in this case, you could not name this angle J. And let me tell you why. Look up here. How many different angles are up here? There's a bunch. There's more than 4. There's probably at least 10. But back over here, if you say angle J, is there going to be confusion about what you're talking about? Yeah, because if you just said angle J, it might be this one. It might be this one. It might be this one. I mean, there's at least, there's probably, I count, there's about 10 or so right here. If you just named this angle J, I would have no idea what you're talking about. So in this case, where there's more than one, this is a no-go. You could not name this angle J. So make sure if you wrote angle J, you put X through that to show this is not the way to name that angle. All right.